All right, we are in section 4.5, solving inequalities with addition and subtraction. So in section 4.4, we learned about keywords that we're looking for when we're writing inequalities. And most importantly, we actually learned how to graph inequalities, and that's a really big part of today's lesson. Okay, so some need-to-know information. We actually are going to solve inequalities the same way that we solved equations. So we use inverse operations to solve inequalities, just like we solve equations. And we always read the variable first in our solution. That's so important when it comes to graphing. We'll see some of that here in the examples in just a second. All right, so example 1, solve the inequality and graph your solution. So we have x minus 5 is less than negative 3. Well, if this was an equation, we would add 5 to isolate the x to get negative 5 to cancel. So that's exactly what we're going to do here too. We're just going to add 5 to both sides, and x is less than 2 because negative 3 plus 5 is 2. Now that we have our solution, we're going to come down here and graph it. Remember, 3 numbers go on the graph, and the solution is the middle number on our graph. And then we just think of, okay, this is a positive 2, so the next number less than 2 would be 1, and greater than 2 would be 3. All right, and remember, our inequality symbol tells us if it's going to be an open dot or a closed dot. If it's just less than or greater than, then it's going to be an open dot. All right, and because it is less than, okay, so here's where reading the variable first is important. This is saying that all numbers, all right, that's what the variable means, all numbers less than 2 are solutions. So less than would mean the arrow goes left, and I've graphed my solution. All right, now let's come over here to the next one. We will occasionally have decimals, but we can handle them the same way. We have b minus 3.8. So I want you to write down this inequality and then try to figure out what operation is going to get b by itself. All right, so we should be thinking to add 3.8. All right, this is not a new concept because, again, we solved equations the same way. So b is now less than or equal to 5.5. All right, so we come down here to our number line, and what number do you think goes right in the middle? All right, maybe you're thinking 5.5. Okay, because that's our solution. And now, really and truly, guys, I mean, you could go down a whole unit and say 4.5, or you could just go down half and say 5, as long as this number to the left is less than 5.5, okay? So we could just say 5 and 6, okay? We're just basically showing how it falls on the number line, all right? And what do you think, open dot or closed? Right, so hopefully you're thinking closed dot because of the equal to bar underneath the sign. So because it's an equal to bar, this is going to be a closed dot. And again, it's b is less than or equal to negative or just positive 5.5, so my arrow goes to the left. All right, so now I want you guys to solve this next one and compare your answers. Just with a buddy maybe sitting behind you or in front of you, just to see if you got it right. So just take a minute to work this problem. Okay, so let's see what our answer looks like. If we add 6 to both sides, and y is greater than negative 1. All right, so we're going to come down here and we're going to graph our solution now. We graph all of our solutions. We always graph our solutions, all right, for inequalities on the number line. And notice now my solution was negative, so I have to, again, think of my negative values. The next number that's less than negative 1 is negative 2, okay? So that's an open dot on the -1 on the solution, but now it's greater than. Y is greater than -1. So all my solutions are greater than -1. My arrow goes to the right. Okay, now example 2 is pretty similar to example 1. There's just a couple things that we want to point out here. All right, we're still using inverse operations, and with equations, we talked about when they're essentially written backwards, meaning the variable comes after the inequality or the equal sign, we like to switch them around. Well, that can get confusing with inequalities, so I would recommend that you don't do that. All right, instead, let's just follow our inverse operations. How could I get 14 to cancel to the other side? All right, hopefully you're thinking to subtract 14. That would be correct. All right, so now 13 minus 14 is -1, and then I bring down my x. All right, so here's where we can run into some trouble with our graph. Okay, so we have 3 values. -1, what number goes to the left? Should be thinking -2, and then 0. But I have to read my answer variable first. My solution is not -1 is less than or equal to x. If you read it that way, you're going to try to draw your arrow to the left. You have to read it. All solutions, all numbers are going to be greater than or equal to -1. You have to read the variable first. X is greater than or equal to -1. All right, so it's still going to be a closed dot because it has the equal to bar, but now my arrow goes to the right for greater than. All right, so it's really important anytime that variable comes after the inequality that you still read it first when you're setting up your graph. All right, let's go ahead and set up the second inequality. Okay, so when you do this, again, so I had on the last quiz, and that's one reason I put this problem on here, is I've seen in some of your quizzes that you guys are having trouble when you see a fraction. But remember, it's what operation is connecting the fraction to the variable, and that's addition. So I just have to subtract it, okay, to get it to cancel out. And now I subtract 3/4 over here, okay? And so now I have x is greater than 4.75. Or you could have said 4 3/4. I just think that decimals are easier to graph on the number line. All right, so I have 4.75. And again, just put some value that's less than that. You don't necessarily have to stick with the decimals. So we could say 4, and we could put, you know, a 5 or a 6 above it. Okay, so that's fine as long as the numbers are less than or greater than whenever it says decimals. Okay, so now is it going to be an open dot or a closed dot? All right, we should be saying open dot because there's no equal to. Okay, and x is greater than 4.75, so my arrow goes to the right. All right, now I want you to try one. Okay, go ahead and try to solve this inequality and graph your solution. Okay, so we need to subtract 3 from both sides, and w is less than or equal to -4. So again, we're graphing a negative solution, which is no big deal. Remember, the solution goes in the middle. What number would go to the left? Would it be -5 or -3? Hopefully you're thinking -5, that's correct, and -3 on the other side. Open or closed dot on -4? It's a closed dot because we have the equal to bar underneath the symbol. Okay, so less than would be going to the left. All right, so hopefully you got that one right. And now let's look at this challenge question. So now we see that we have some solution that is already graphed, and we have to come up with the inequality that would represent the graph. All right, so I just want to give you a minute to think about this. All right, we know enough about inequalities that maybe we would be able to kind of guess at what the symbol would be, what the solution would be. And I just want to go ahead and suggest that you need to write the variable first. That makes it a little easier. So you try to figure out what inequality would go here. All right. Well, we know because it's a closed dot that it's going to have the equal to bar. And we know because the arrow is going to the right that it's greater than or equal to. And we know because of the point that it's plotted on that our solution is 2. So x is greater than or equal to 2. All right, would be how we would write that. Okay, so now let's look at the word problem example. To become an astronaut pilot for NASA, a person can be no taller than 6.25 feet or 6.25 feet. Your friend is 5 feet 9 inches tall. How much can your friend grow and still meet the requirement? Okay, so the first thing we need to do is kind of notice here that we have our dimensions written in different units. One is as a decimal and the other one says 5 feet 9 inches. So I need to convert this 5 feet 9 inches to decimal version, and it can't just be 5.9. All right, so we know that there are 9 inches given what we have in the word problem, but how many inches are in a foot? All right, we know that that's 12, so 9 over 12 converts to 0.75 feet. So we can combine that with the 5 feet tall that your friend already is, and we know the friend is 5.75 feet tall. Okay, we had to do that so we're actually comparing the units in the same, or the values in the same unit, so we can now put it into an inequality. All right, so we know that they can be no taller than 6.25 feet, okay? That means that this value has to be less than or equal to 6.25. We know that your friend is already 5.75, but we don't know how much taller they can grow, that's what our h is, in order for them to still meet the requirement. And now we're going to just solve the inequality. Subtract 5.75 from both sides. All right, and they can grow no more than half a foot, which we know is how many inches? All right, 6 inches. Okay, and that's everything you need to know for this lesson. So what I want to do now is just take a few minutes to work on some classwork. We wrap up the class. And that's everything you need to know for section 4.5.